Welcome over here, folks, and we're looking at optimization problems, and we are going to do question number 24. So 24 is over here. I'm going to read it. It says, a rectangle is bounded by the x and y axis, and the graph of y equals 6 minus x over 2, and then we're going to look at a figure. What length and width should the rectangle have so that its area is maximum? And the picture is this picture here. So we're going to refer to this, and Shiomara is going to walk us through this problem. Go ahead, Shiomara, whenever you're ready.
So we're going to start by drawing off the picture, which looks like this. It's a graph, since it's bound on the x and the y axis.
This will be in your homework, this will be in the book, okay? Of what you get at the top of it.
Okay, so since it says it's bound on the y, this is the y and this is the x, and we have to find the maximum value, and there's an equation given. It's y equals 6 minus x over 2, and the to find the area of the area, it's
what kind of shape is it, Shiomara?
a triangle.
Not a triangle.
Rectangle.
Rectangle, there we go. More time.
So the area of the rectangle is base times height, which would be x times y. And since we already have two equations, which would be this one and the y equals 6 minus x over 2, we would just plug in the y, the equation already giving for the y, so it'd be x times 6 minus x over 2, and then you could just multiply the x and the y, so it'd be
Did you put parentheses around 6 minus x?
It'd be 6x minus x squared over 2, and then you could factor out an x, so it turns to x, and the 2 follows the x, so it's x over 2 times 6 minus x, and then you would distribute the x over 2 to this equation, so it's 6x over 2 minus x squared over 2, and you would simplify, so it would turn to 3x minus x. Minus 1/2, because you could imagine a 1 there, so it's a
X squared.
1/2 x squared.
Here you go.
So it'd be 1/2 x squared. And
So Shiomara, you have your equation now, right?
yes.
So now what do you do after you have your equation?
Once you have your equation, you take the derivative and set equal to 0. So it's 3x. And it would be just 3 minus x, since you multiply the 2 times the 1/2 and it just turns into 1 or 0. And then you set it equal to 0, and you subtract 3
Good.
on both sides, and you get x equals 3. And then you would just plug this answer
Where?
back into, oh yeah, -3, and then divide by,
Oh, would it be -3?
no, because you would divide by, yeah, but then you divide by -1. Because it's -x equals -3, you divide the -1. And then you would just plug this back into the original equation, which is, so you plug it in back into the y equals 6 minus x over 2. So it'd be y equals 6 minus 3 over 2 and equals y equals 3 over 2.
Okay.
So these are your two.
So, and then just to clarify, Shiomara, these are the dimensions. This over here, could you write this as x here? This was x in your picture, and this is y over here, right? Right. So this is a way, and we found the dimensions, right? That's what the question asked, right?
Yeah.
Okay. Nice job, Shiomara. Good work. Can we give it up for Shiomara, please?